क्या हुआ? 86
Nitin sir, good morning.
So you can.
Subasa, am I audible?
Yes.
Clear, right?
But I'm not. You have to put the screen on.
Yes, sir. You can see me on the screen?
No.
No?
No, it has changed. I think something.
Okay. Nitin sir, very good morning.
Good morning, sir. How are
Good
you,
morning,
sir?
guys.
Good morning.
Good morning.
Peter sir, very good morning.
Very good morning, sir.
Good morning, guys.
IPP,
Good morning.
BPBP.
Uh,
Cool, cool.
where
Are we
is our
waiting for something? Somebody? Or
Sorry?
are we waiting for somebody?
Yeah, just 1 minute, sir. Like, small setting is going on, sir.
Okay, right.
Just 1 minute, 1 minute. All done, all set.
You tell me when to start the main
Yeah.
present.
So will I.
So,
Close the door. Sir? No, please. Yes, sir. IVP, good to go.
yes,
Peter sir, we can go. Go. We can
Yeah,
start.
please start. Yeah.
Yes, yes. Prince, you can start.
Prashant is going to take it over, right?
Yeah.
Is it so? If not, okay. Just
You
Good
can
morning,
start. You can
everybody.
just give me a second. Just give me a second.
Yeah, yeah. Graduate. Okay,
Good morning, ladies and gentlemen. Welcome everybody to this persona training. The HGF Prince Pinto, President of Asia Macro Lalbagh, call this meeting to order. We have today Mr. Chandra with us. Welcome you, sir, to this persona training, and all the regular guests as well as there are a lot of visitors who have come to this regular persona training. I welcome everybody. I would request JC Nitin Shetty, our past president, to help us with introduction of today's speaker.
Thank you, President. President of today's web series and each and everyone who is part of this, it's my privilege to introduce in short today's speaker, Mr. Subhash Chandra Basu. He graduated in architecture in 1981 from BE College, Shibpur under Calcutta University. The brief association with Sri Aurobindo Society at Pondicherry, he joined KSCST, Bangalore, and worked in close association with Astra up to 1993. For 1.5 decades, he has served in Malnad College of Engineering as a faculty in Department of Architecture, initiated in alternative building materials and constructions. At his interest expanded to vernacular architecture, conservations, and passive solar architecture. For the last 5 years, he is in Mangalore. He is involved with Grama Vidya, Mangalore Center, and set up active on InTouch Mangalore chapter at Kodial Guttu. So here is our today's guest speaker, Mr. Subhash Chandra Basu. Thank you, President.
Thank you very much, JC Nitin Shetty, our past president. It's been really wonderful to have such a person which is very much about the architecture. Thank you, Nitin Shetty. And over to you, Mr. Chandra sir. We would eager to hear from you. Welcome to Persona. Yeah. Sir? Am I audible, sir? Mr. Chandra?
Subha sir, you can start.
Okay. Good morning, everybody. So I'm going to start today's discussion. And as you have seen on the screen, that I'm going to discuss about how to build with care for the earth. Now, most of the things that we are going to discuss today will be about green buildings, about alternative architecture. Now, it's necessary for me in the beginning to define what is alternative or green architecture. Usually, when we look at the building and our surroundings, we have building made out of brick and concrete and glass and steel. But most of these buildings uses a lot of energy. So we are going to identify the alternative of green building, which uses less energy, water, natural resources, and create less waste and create a healthier atmosphere for the people those are going to live in. So that's going to be a very simple definition for us. Next. So now the question is why we need to get into this whole area when everything is going smooth, although we know there are problems with environment and other things. Now, building construction is one of the most resource-intensive sector, where brick, cement, steel, aluminium, ceramic tiles, glasses, and all this material, they are actually transported over a long distance, and they are processed in large industry, which consumes huge amount of energy and huge amount of water also for its production and sustenance. And it will be also consuming huge amount of our pristine forest area. Now, the total emission that we sometimes see is goes nearly 75% of the global emission. Although being an architect and engineers, we always kind of behave as if we are doing some great work for the society, but each of our decision and selection of material actually leads to a lot of different kind of impact on the global environment. Next. Now, it all started with the so-called development that we see around. It happened more with the Industrial Revolution, that we got into powerful engines and coal and other things to pull things out from a far off places and things like that. The picture actually indicates a whole tree, a huge tree, which is logged and taken out from the forest. And this is for the kind of development that we are will be looking for for the last 200 years. Next. Now, this also brings out a huge number of people from the rural hinterland to the urban areas. The urban areas is also an outcome of the kind of development that we are talking about. And then we don't house them properly, they will be somehow managing to live on the outskirts of the cities, and they are the people actually who build the cities and the kind of developed world that we see as next. But the people, those who are building or living in large apartment or houses, are we all living a very healthy life? If we kind of look at it, the picture, we'll see that we are actually surrounded with toxic paints. We have radiating gadgets, we have gases and adhesives, which is using toxic gases, insecticides, dust mite, room freshener, everything has a kind of a bad health impact on us. Now, this is the kind of indoor space that we create. Next. And the model of that we have in our mind, particularly our politicians and engineers and technocrats, those who goes abroad and comes back with this kind of image that you see, that we like to have our cities to be like that. Next. Now, then there are reactions, and we start thinking about how to correct it. So there are lots of new ideas comes into picture, and we name them also in different way. Somewhere we call it ecological design, low cost, low carbon building, green buildings, eco-friendly designs. But they are all different names for kind of things that we like to achieve or solve the problem of what we have created our own. Next. Now, whole issue starts technically with the energy in building. Now, one type of energy is embodied into our building. The type of building that we see, the steel, concrete, and all this, has got huge amount of energy embedded within. Then we have the energy used during construction. Today, we use a lot of equipments and heavy machineries to erect our building. Then we have operational energy for services like lighting, ventilation, and AC, and all those things which are very common now for our lifestyle. Then we have maintenance and alteration. Those buildings need a lot of them. And then energy for, lastly, energy for demolition, recycling. All those things. Now, see, we have created such a huge problem. And this energy, ultimately, whenever we consume energy, we actually throw a lot of waste energy, which heats up the whole environment. So it is very essential for us that we have to select what technology we will use, what material to be used for future construction. Next. Next. Now, in the process of extracting this material, we are actually creating huge amount of scar on the face of the earth. Somewhere we are actually scooping out, somewhere we are tracing it out. And, as we look at the earth from the top now, we see all these things happening all around our cities. And what we are doing is a kind of, exhausting the finite resources of building material. Next. But do we have a way to come out of it? Now, we do have vernacular wisdom. We still have our villages where we can go back and look at the way people lived for hundreds of thousands of years. They do have some kind of understanding of their local climate and material and its performance. And it is worth still to look at some of them to draw some kind of inspiration from it. Next. Now, there are examples where people, those who have set these things for us, they have provided examples for us, and perhaps Gandhi, when he decided to build his own ashram in Wardha, that was in 1938, he used local material like bamboo, mud, and tiles for his own ashram. And that is still very much there at Sevagram Wardha, which one can't look at and draw inspiration from it. Next. There are buildings also which is big and multi-storied, and one such building is in a guest house called this now in Sri Aurobindo Ashram, and this is known as Golconda. And this is one building again which has a tremendous impact on us, because it's actually responded to the climatic context that we have. It can open up from everywhere to provide the ventilation, which is a very important need for a hot and humid climate. It's not the AC which can solve all our problems, but without much energy, we can still negotiate with it. This example shows us that. Next. Now, in 80s, we have a group of professors from Indian Institute of Science, IISc. They formulated a group called Astra, which is known as CST nowadays. They started working with some of the technologies and ideas which perhaps can help us to come out of this or to solve partly some of this problem. And I happen to associate myself early with this group in FAGs. Next. There are people who also, they have set the stage for us. Laurie Baker is one of them. And in 70s, he started working in Kerala. He contributed quite a lot in terms of his work. And he has done a lot of building using efficiently the local resources like brick and tiles. So again, to respond to the local climate, these buildings were open enough for ventilation, things like that. So they worked as a very important exploration for us to draw inspiration. So then onwards, we have our own buildings coming up in different places of Bangalore, Mysore, and other places. Next. Here's one example for Mysore. You can see vaulted roof, you can see mud block, which we'll discuss later. Next. Next. There are lots of other issues starting with the building and building materials. One of the things is water. We have problem of water, and we don't sometimes think that we are creating any problem by building different way. But if we look at the consumption of water in production of this material, like 1 ton of cement, which consumes 3.6 tons of water, or 1 ton of paper, which consumes 270 tons of water. Steel uses 300 tons of water. Now, these are something which is very mind-boggling, basically because very rarely we have time to look at some of this information to understand that what kind of problem we are creating for society when you use this material, or rather misuse some of this material. Thanks. We do have quite a lot of faulty designs in our buildings, like the toilet system that we have, the WCs, which consumes a huge amount of water, the water which is very precious, treated for us. Now, this is also used, this huge amount of water is also used to push this solid material out into the pipe, to push it into ultimately to the sea or river or wherever it is. Very rarely it gets treated, particularly in this matter. So we need to think about the type of use of water and all these things, and it all originates from inside of buildings. Next. We do have new ideas coming up to treat some of them, and we need to look at some of these things for our future. Next. We need to relate it with our food production. We need to have kitchen garden and other things so that we can consume it locally. We need to also think about how we travel to our workplace. I think pandemic has taught us this lesson. So we were all talking about working from home. This is the time that people have forced us to look at these options. So these are some of the things where we can select these options of working in a place which is very close to our office and other things, and work as much as possible to reduce the amount of vehicles that is operated on the streets. Next. Next. The kind of city that we create by creating the Western model, particularly using vehicles and traveling to the office, it creates a huge amount of parking lots all around in the city, and it demands these things, these spaces. Now, if we start working from home, if we work from home, we'll suddenly realize that our cityscape is changing, and that is something which can happen in a better way. Next. But there are interesting examples also coming up now. Next. You have smaller countries, those who have opened up these issues and created a lot of interesting situations where people can ride bicycle within the city, where the roads are blocked for the traffic to the walkers and the bicyclists. So these are some of the hope that we have for future. Next. Ultimately, we are looking at a situation that we like to have a green city, but we have to go through green neighborhood, and it starts with the green architecture. So I'll come back now to the architectural part of it. Next. 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 Now I'll start with the journey, my journey with Gram Vidya. Gram Vidya is an NGO which is dedicated to building research and training. It started in 1988, and today we are still working on it. Next. So we will look at certain technologies and their contextual adaptation, which is meaningful based on whatever context that I have created by my earlier presentation. We are looking at, in our center, looking at earth-based walling material and construction techniques. And we are also looking at different developments of masonry roofing techniques like domes and walls, and improved RCC roofing technique, beams and panels, and ferrocement. So these are some of the things I will touch upon, mainly from the point of view of example, not going into the integrities of the technology. Basically, that will take a long time. Next. So the kind of thing that we are working is, it starts with a stabilized mud block. Next. Stabilized adobe. Next. It also talks about rammed earth. These are different techniques using mud or earth as a basic raw material, and stabilized mud concrete at the end. Next. We'll discuss now a little about stabilized mud block. This is a art-based product, which is actually compressed art using a hand-operated machine. Next. With stabilization, which is in the form of around 7 to 8% of cement and little of lime. Next. So these are some of the early examples. Dr. Yogananda's residence in 1987. It's a two-story building using only block and load bearing. This is another thing that is very important for us to remember. Most of the work that we are doing are with load bearing structure. On the contrary, the regular construction that goes on, they all use RCC frame structure. That means a column, beam, and slab. Whereas we try to give emphasis on the strength of the material, like the mud block. It should be used for carrying load rather than just standing as a kind of partition. So next building that we see is a load-bearing structure, which is around 3 or 4 story high. So it shows that you don't need to use RCC column even to build a 4 stories, up to a 4 or 5 story building. Next. Next. This is also to show you that this material can be used for even buildings like hospital. In this case, it is a 2-story hospital blocks in Gudalur, which is a high rainfall area on the Nilgiris. We have also corporate office in Solingur, which is a previous group of people's office building. So you can see the acceptance in the corporate sector. You can see its acceptance in the NGO sector, where we're doing hospitals and hospitals. Next. Now, Bhuj, after the earthquake, used a lot of these blocks. I don't know, things have not come onto the screen, but we did a huge amount of training for block making and utilize these blocks for the traditional kind of construction that they do, but only replacing it with stabilized earth block. Next. As you see, this is a training and the traditional houses built with earthen blocks. Next. Now we discuss a little about stabilize the dough. In earlier case, we showed how a simple hand-operated machine at the side can produce blocks. In this case, we will show you how stabilize a dough, which is handmade. A dough is handmade product. With a simple mold, steel or wooden mold, we produce all these blocks at the site. And here is a site in Bangalore where they have used the same blocks for again a 3-story building. Next. We have used it for self-help housing around Bangalore, where the owner of the house, they participated in making the blocks and build their own house. We have used it for a yoga center in Assam, for Malland College of Engineering. Next. Now we come to the rammed earth. Stabilized rammed earth construction in Tiruvannamalai for a residence. Next. Rammed earth is also used in Bhuj, where the whole house could build with the simple formwork. And since it has been used several times, thousands of times, so they could actually create a single formwork for the whole building. Next. And they could build the bunga, the traditional kind of house construction. Yeah. Next. Last thing that we'll be taking up is mud concrete. Mud concrete is something which we are using regularly nowadays, which is using or recycling the waste building products, using it with mud and molded it, or under the formwork, we can cast it like concrete also. In this case, there's a school building in Chutlingi in Tamil Nadu, which has been done with this mud concrete block. That's a finished school building, you can see later on. Next. Very recently, we did a Goshala in Mangalore. This is one of my early work here. And this is the mud concrete pillars, the standing on mud concrete pillars, which is using the recycled product, particularly the waste that comes from the laterite block making or squaring. And at the site also, we have lots of this waste with a little bit of mud and cement and lime mixed together with casted, as I call them, without steel. These are without steel. This is just like this. Next. Then we come to the roof, and in the roofing, there are pillar slab, composite beam panel roof, masonry wall, masonry dome, and masonry pyramid, and ferroconcrete. All these things we'll touch upon with one or two examples. Next. You can see here, filler slab is nothing but a little modification of the existing RCC slab. And here what we do, we remove some amount of the material like concrete by fill-up material, which can be brick, it can be block, it can be any light material or recycled material, because we don't expect much strength out of it, and we are replacing some of the concrete which is not doing much here. So that is why it is called filler slab. And you can see the construction technique where the steel is passing in between those blocks, and you create also very interesting ceiling pattern in the process. Next. We can also use variety of building material for pillar, like the waste or recycled tiles. Actually, Lorry Baker started using these tiles, which is coming out of the Mangalore tile, but not the best quality. It is only the 3rd grade or 4th grade kind of things, which is already having some cracks. We can use also the products made by the village potters, and all these things can create employment and a new type of architecture. Next. The next one is a composite beam panel roof. If we look back to our history I mean, before the RCC took over, we used to have roof like a Jackass roof, and Madras terrace and things like that. And if we draw our inspirations from that, we see that there is a possibility of creating beam and panel. Now, beam can be steel, it can be RCC, it can be also made out of timber. And then we can create panels out of bricks or tiles or stone slabs and create a beam panel roofing system. And this is a designed roof, and it's against steel and time if we like to prefabricate it and do the things. Next. We also started using masonry vaulted roof. Now, these are the techniques which is there in our tradition. But the only thing in the traditionally, I mean, if we look at the period of Tipu, we find plenty of this kind of brick vaulted roof around. But most of them are very thick. And today, with a little bit of engineering knowledge, we could reduce the thickness of the roof. And with very nominal use of steel, we could create large fan structures also. Now, this is one such example. Next. You see that you can also play around with the geometry of the vaults. This is from Vellore. And you can also use it for thermal performance. Like we have a double roof. We have a roof below, which is made out of mud blocks, and then a tile roof on the top. A double roof also will provide you a lot of thermal comfort, particularly area where the temperature goes close to 40 degrees. Next. There are also large vaulted structure where we have used vault also as a kind of a flow slab, and its potential can be explored. And this is an example from a house very close to Malpe Bridge in Udupi. Next. There's another example in Mangalore where architect Nitin Jain was involved. We were also just as a consultant visited the site for making mud blocks and also for the construction of the dome. It's a 30 feet diameter dome with mud block, and the whole house is planned to be like. Next. This domes also need not be very high or spherical things. No, it can be very shallow so that you can build another floor on the top. So historically, this kind of examples are very much there. And again, we have revived some of them with the proper design. Here is one example of the residence value. Next. We can also do pyramidal roof using mud block. Here is another example from MC Hassan, where we have used old timber frames to initially support the roof and use mud block again for creating the pyramidal shape for meditation center. Next. Last things that we like to discuss is the concrete ferrocement channel, where we use a very nominal amount of steel in the form of chicken mesh and few rods. And we can precast elements like channels and things like that, and then can lift and place them side by side to create a system. This is lighter, again saves a lot of steel and cement that is necessary, and can be erected very fast. And this example comes from again Kingsley Health Center, a hospital building using the same. Next. Now, the last thing that I like to discuss in last 2-3 minutes is that things that we are a group, we are interested about research, training, and development, and also execution in certain cases. But the area that we feel today is very important is sharing our experiences with the younger children, starting from school, college, to whatever age people. But the trust is very much with the younger. Now, this is a kind of hands-on workshop that is going on with the school children. As you can see, that the through a little bit of play with mud. They learn how to even mold a brick, which is a very, very basic experience that we should have. People sometimes they don't know where this bricks and blocks and cement comes from and how dangerous it is the factory when you produce them. But if they know the basic process, so they really grow with it. So here you can see the children in a school, Bangalore school, they are making mud blocks and appreciate it. Next. We do a lot of workshops with the students of architecture and engineering. Here you can see they are intensely listening to the things. The mud block making machine is there. So they will be making and preparing blocks themselves, which gives them tremendous amount of confidence to get into the profession in the near future. Next. And this is our regular training program activities. In Bangalore also, we are doing it for last 3-4 years. Before that, I was associated with Indian Institute of Science and our Grambita program in Bangalore. So both the places we still continue with this training program, where people from different professions can come together and can put their hand to understand and build things their own. So this is something which is very, very critical for us. And in the end, I like to say that I'm touching only few small, but ultimately it is your lifestyle. Until unless you change, you won't be able to appreciate the value of it. And when you like to build a house, there are so many components, starting from the building openings, foundation, finishing. And today, we are kind of seduced by all kinds of environment and the material that is coming into picture. And they are not only costly, they also become very energy intensive. So one has to be very careful about selecting those material and technologies if you like to build. And if you select the alternatives, you are close to working with the heart to protect. I will end here, I think at 40 minutes. So this is open for further discussions.
So it was a
Yes.
lot of information, something new, going back to our history. So I'd like the participant to come up with their questions. Peter sir, we can't hear you. You are on mute.
Thank you, sir, for sharing the very good information on eco-friendly structure and the olden things, and as well as what is the future. We are talking about giving awareness to school children. Is it a regular activity, or it is once in a while you are doing, or do you partner with any of the school or any NGOs or any institutions like Rotary Lions or JCA?
Yeah, this is a kind of activity we usually take up whenever somebody offer this chance to us. We usually don't go and try to tell them that we like to do it, but we try to explain it to the teachers and the management. If they are willing, we usually then drop in and try to involve them into this. It's not a regular day-to-day based program. It's only done whenever there is a kind of a request coming from an NGO or a school.
Sure, sir. Thank you very much. We are interested to know more about it, and if it is possible, we can try to some other people.
Yes, you are always welcome, and we can drop into our Bodiyal Guttu building, where we do have some of these examples in a small way, so that we can share it with you.
one more question, sir.
Yeah.
Actually, when you see some kind of ancient look or something like you are using with mud and all kind of construction things, there is a phobia that there are people understand that it is very expensive compared to the current running material which is available in the available for us. So how you can justify the cost effectiveness in this?
Yeah, interestingly, when you talk about mud, it is used in the wall, and the cost of the wall in a whole building is nothing but around 15% of the total cost of the building. So just by using mud, you are not going to reduce the cost of the building. You can reduce it by marginally. So the question is that, what roof you're using, what finishing you're using. And if you are addicted to all the modern finishes, and at the same time you like to use a little bit of mud, it is not going to reduce. So you have to look at all the issues, then you can reduce the cost. But the whole issue is not only the cost, what kind of environmental impact that it has. You use certain things in the name of that it is very strong, but do you need that strength? Everybody says RCC columns and things, but why? If you are building a 1-story, 2-story, 3-story building, you don't need to use them. So that is where you can reduce the cost when you are actually understanding the whole process. And particularly for the middle class and the poor people, if they can get involved in the construction, they can also get the benefit of this kind of. Next.
Thank you, sir. Thank you very much.
Who's next? Hades, I have a question.
Mhm.
So, how is the lifespan like for the construction as compared to your modern technology, RCC?
This is a typical question we face. But interestingly, you see, most of the cases, life of a building depends on its maintenance. If you build a nice building and then leave it for it to decay, you will find that it will decay very fast. But look at the buildings in the villages where they didn't even use cement. Nothing is there, only mud and timber. And they have lasted for hundreds of years. And we don't question. Look at the RCC buildings all around you. They are all rusting. They are only 20, 30 years old here. And I live in Guttu house, which is more than 100 years. And all around me are RCC buildings. I can predict that most of the RCC building will go in another 10, 20 years unless they are maintained, because they leaks badly. And today, all these buildings, again, they are put with a roof on the top to protect them from the rain. So the question of life is very much related to what kind of maintenance that you have. You can die in a small fever also if you don't take care of it in the early stage. So that is the situation. If you take care of the building, so one can then come to the question how often you maintain this building. And maintenance is very much part of our culture earlier, which we are losing. Basically, we don't like to do it ourselves. We always rely on others. So invariably we say, oh, we don't get people to do this little repair work. But no, the Western society already faced this. Today, Western society, all Saturday, Sunday, they have all their tools at home and they do all the repair work, whether it is a tap, whether electricity, everything. So we have to prepare ourselves, do a little bit of maintenance, and everything will be fine. Life, absolutely, there is no problem if we do maintain our life.
Okay, sir. Just to continue with it, sir, like being in the coastal lines, if you have anything related to a metal, okay, it gets corroded very fast because of the salt present in the air, right, sir?
I think it is more corrosive to the steel which has been used. See, if it is mud or timber, it will, but it will not be so bad compared to the steel that being used in this area. When we had no way questioned those things and allowed it to happen, and it's still happening that we use huge amount of steel, I think it is. I think it's bad to then question the mud and bricks and others, which was already proved. There are bricks which is there from Harappa Mohenjo-daro period today, still surviving. There are tiles which have already served a purpose. More than 100 years old tiles are very common here. So mud, yes, it will face problem when it is a heavy rain, but we can take care by a proper design and overhang and a little bit of maintenance. Absolutely no problem. Can manage.
And one more point where you pointed out, sir, like a wall which is made up of mud materials, it keeps a place cool as compared to RCC.
Compared to RCC, yes, in terms of it. But the problem basically is when we go for RCC, we have a tendency to make it thin and thinner. On the contrary, most of the mud walls are very thick because we know that the thickness gives protection, and thickness plays a very important role there. So let us be clear that mud walls are good, but we have to maintain a little bit of thickness. We cannot just thin it down to a few inches, and then even mud wall will have a problem. So let us maintain a basic minimum thickness of nearly a foot or so. And in most of the small towns and others, our land cost is not so high to do that. In the city, yes, you might question a few inches here and there. But in smaller towns and small cities, we still can afford to have a slightly thicker wall and can protect us from the heat.
Yes, sir. Thank you so much, sir. Panduranga sir, you have some questions?
Nothing in specific. It was a pretty interesting discussion. You can hear me, right?
Yes, audible.
Yeah. I've been keenly watching this. In fact, I was keenly waiting for this session. I just wanted to know how safe it is from the perspective of, robbery, theft, and other such things. Particularly if people know in the area that this building has been built using mud blocks. How, let us say, how much can it withstand if somebody wants to, dig into your house and take away your valuables? These are concerns generally the women folk will have. So I just wanted to know how safe it is compared to other, say solid concrete blocks and other things like that.
Most of the cases, the solid concrete blocks, if you put less cement, it will be weaker than mud block. Mud blocks actually, again, can be made very strong and moderately strong based on the amount of cement that you put. The blocks that we generally use in the city, they are with around 7-8% of cement, and their strengths are comparable with the bricks that we use in the market. So that way, it will not have much problem as we are talking about. Nobody will be able to break it so easily. They have to really struggle to do it. So that way, it is far safer compared to the other building material. And particularly concrete, as I said, when you use concrete and you think that we are very safe and you go for a very thin wall, and it is easier to break it. That's it.
Yeah, because people generally tend to go for a thin wall to save on the carpet area.
Yeah.
But what I wanted to know is one more question is that what is the sound attenuation property vis-a-vis concrete? Because external sound, like let us say traffic sounds and other things like that, particularly in heavy traffic areas like let us say Jyoti Circle or Hampankatta, how good is the sound attenuation of your mud block?
There is no specific study as such on that property, but in general, we feel that it is not going to change much. The regular burnt brick or laterite block, whatever property it has, it will more or less continue with a similar kind of properties. Okay. None of these things are actually designed to take care of the noise level and things like that. So it has to be specifically looked at only on the surface which is facing that kind of sources of sound.
No, because particularly office buildings, let us
Yeah.
say you have say 1+2 already, and you want to build on top of that, then these things become very, very important.
Yeah, but if you like to deal with it, you have to deal with it separately. Like any other building material, it will behave the same.
Okay.
That's it.
Yeah. Anybody else with the questions?
Yeah, does anybody have the question?
Sorry, yeah, President.
No. If not, we'll ask Peter to give us with a vote of thanks. Peter, founder president.
Yeah, good morning once again. It's my privilege to introduce our new president who has just taken a presidentship last Thursday as president of JCI Mangalore Lal Park, JCHF Prashant B. Shetty. I'm sure he's there here. Let me introduce his hobbies. He's a very people-friendly person. Want to construct more of team activities as well as to give a very good information as well as awareness in various social issues, culture, sports, and a lot of activities. I'm very sure this is the 36th session which we are conducting after COVID, and this will continue under his leadership. And I thank Pritam for taking care of the sessions on behalf of JCI Mangalore Lal Bagh. I from Preston Knowledge Foundation and thank all of you for giving us the opportunity to spread this knowledge every Sunday at 11 o'clock to the needy as well as for the participants. I thank Praveen Udupa also for supporting this cause from A1 Logic. I'm very sure you will continue the same support to the next president, JCJ Prashant Shetty, and let us work together and do little more to the society wherever possible. Now over to JCJF Prashant B. Shetty to conclude the session with vote of thanks.
Prashant?
Yes, sir.
Yeah, you unmuted. Perfect. Over to you, Prashant.
Thank you very much, Peter, sir. Thank you very much, Peter, sir. And thank you, IPP, for having those fantastic 36 sessions in your tenure. In fact, everybody say COVID, it is pandemic, but for us, it was like a blessing in disguise. We had 35 fantastic sessions, and as well as today, the 36th one. With the experienced person like Subhash Chandra Basu sir, and the topic which is the need of the hour for us under these circumstances. Like anyway, we are feeling in Mangalore right now. It's hot, humid conditions. So the fantastic topic we had today, and now we shall try to go ahead and for further probably in my time. We will continue throughout the year. Every Sunday we'll have more and more sessions of this kind. And once again, I would like to thank our today's speaker, Subhash Chandra Basu sir, who's an experienced architect coordinator from Gram Vidya's Mangalore Center. Sir, thank you very much for being here, sir. We would seek your cooperation in the future also in this regard.
Thank you.
Thank you, IPP sir. And again, I should congratulate and thank our past president Nitin Shetty sir for coordinating with all the things related to persona. Thank you very much from my side.
Thanks for the privilege.
Thank you. Thank you.
Yeah.
Okay.
Prashant, you can wind up the.
Yeah, fine. Once again, while thanking everyone who is present over here, I request your cooperation in the future also. More and more sessions we'll have related to this in this persona. We'll try to add up more and more people from our zone, the other loans also. We will have, we'll try to have very good session with your cooperation. So finally, I would like to thank our guest again for your wonderful session, sir, and our IPP, our founder president, all our past presidents, and the people who are participating continuously in this persona program.